Tornadoes are one of our planet's most awesome forces of nature. And the United States has the largest number and the most devastating tornadoes in the world. Meet National Geographic's Tim Samaras, our Jason host researcher. Tim's a storm chaser.
It's amazing how light this thing becomes when you get full of adrenaline.
Every May and June, he travels over 30,000 miles in a customized truck loaded with sophisticated monitoring equipment. Tim stalks tornadoes in order to study them, and not from a distance. He gets right into the path of major twisters in order to discover what's going on inside the whirling vortex. You're going with Tim on a run through Tornado Alley. Your mission: explore how tornadoes are formed, understand the tools used to forecast and study tornadoes. To be a storm chaser, you'll need some basic tools and skills. You will have to know how to detect dew point, determine the dry line, track the formation of thunderstorms, observe how some supercells evolve into tornadoes, collect and analyze data from a tornado. Let's listen in as Tim briefs our Argo team on the basics of how tornadoes form.
A tornado is a violently rotating column of air with speeds close to anywhere between 200 to 300 miles per hour. They last anywhere from 60 seconds to hours.
But pinpointing exactly where a tornado will strike is one of the hardest parts of Tim's job. He starts with the geographical area where they are most likely to form, and surface boundaries that act as tornado predictors.
Tornado Alley is basically in the heart of America. It's outlined as probably eastern Colorado to Missouri to South Dakota to Texas. It's a footprint where tornadoes occur the most frequent over the springtime.
The terrain in Tornado Alley is relatively flat, allowing moist tropical air from the Gulf of Mexico to collide with dry, cooler air from the north and the west. This creates what is called a dry line. The dry line is a boundary where moist air meets dry air. To find the dry line, Tim uses an important measurement called dew point. Dew point is the temperature at which water vapor begins to condense into liquid water. When a region with a low dew point meets a region with a higher dew point, a dry line occurs. Tim knows that in Tornado Alley, intense thunderstorms often form just east of these dry lines, and this is where the most violent tornadoes form.
Typically, what we're waiting for is for the sun, the transfer of energy, to heat the ground, to cause these thermals to start building. And once they start building and creating these updrafts, they turn into thunderstorms. And when the thunderstorms are powerful enough, they become supercells. The warm air gets driven up in the updraft. The upper level winds picks that moisture up and pushes it downstream.
Tim has turned his truck into a rolling laboratory, allowing him to analyze weather data. Looking at this information helps him determine the dry line. Tim predicts a storm forming nearby and races to the scene. His prediction is on target. A huge supercell is forming in the sky. This most hazardous of all thunderstorms is marked by powerful rotating winds. The twisting clouds are another indication that a tornado may soon strike. As the rotation becomes concentrated, a narrow column or funnel of rapidly spinning air descends from the base of the storm. By the time the funnel cloud touches down on the Earth's surface, it's a fully formed tornado. This tornado is nearly on top of Tim's current position, about 100 yards away. He races to deploy his research probe directly in its path. This cone will measure data right inside the center of the twisting winds.
Getting the probes in the path of the tornado is extremely difficult. Generally, when we get ready to deploy, we're only just a couple of minutes before tornado passage, so everything happens within the first 15 minutes.
When the coast is clear, it's time to go back to assess the damage and see how the probes fared. The tornado rolled right over the probes. Initial readings show the winds blowing over 200 miles per hour. This was one of the most incredible tornadoes that Tim has ever seen. Fortunately, no one was killed, and Tim was able to gather a lot of data, thanks in large part to the fortified probes. The video probes are equipped with 7 cameras and sensors to provide footage from inside a tornado.
This is actually my probe that measures the meteorological conditions of a tornado. It measures temperature, measures pressure, it measures relative humidity, and it actually measures wind speed and direction.
Wow.
Tim designed the probes himself. His engineering background helped him create an instrument that could be placed on the ground without an anchor, yet still withstand wind speeds of hundreds of miles per hour without flying away.
Most of the things that I know actually came from on-hands experience, believe it or not. Getting my hands in there and building. I mean, I've been a lifelong experimenter, electronics experimenter and tinkerer since I was 6 or 7 years old.
Tim analyzes the data and shares it with scientists all over the world so they can interpret the findings. He's especially interested in measuring the dynamics of the lowest 30 feet of tornadoes, the least understood part of a twister. Tornadoes are measured according to the enhanced Fujita scale, which rates wind speed by assessing the damage done on the ground. An EF0 tornado may snap tree branches or damage chimneys. The scale increases proportionately to an EF5, the most dangerous of all. An EF5 tornado can lift a well-built house from its foundation and send trucks flying through the air. Take a closer look at the footage from Tim's probe.
You can actually see a piece of farm equipment rotating violently within the tornado. This item right here is a 1,000-pound corn bin that got caught in the outer edge of the circulation of this tornado. And I estimated this corn bin is moving close to 100 miles per hour.
Tim believes that understanding the dynamics of the lowest 30 feet of a tornado is critical.
The bottom 30 feet is where we all live. So if we understood the wind fields, we can probably take that information and apply it to the better construction of homes.
As we learn more about the unpredictable patterns of a tornado, eventually we'll be able to create a safer environment in places like Tornado Alley and be better able to predict when these massive storms might strike. Let's recap. We have learned about dew point, the dry line, thunderstorm, supercell, and tornado formation. We can now collect and analyze weather data, all in order to learn how to alert our communities of impending storms. Now that you've been briefed, it's time to move on to the next part of your mission. Good luck, Argonauts.
The Jason Project. Start your mission at www.jason.org.